Hello, everyone. Very good morning to your authors and invited guests. Welcome to Technical Session 3D. Myself, Karthik Bharadwaj, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Solistic LLP, it's my pleasure to welcome you to the 8th World Conference on Smart Trends in System, Security and Sustainability, World S4 2024, London, UK. The 8th edition of the conference is being organized in a hybrid mode. The physical event was organized yesterday in London, UK, and the virtual event is being held through Zoom from 24 to 26 July 2024. So I welcome all the guests and session chair. We will be starting the session in 5 minutes. Thank you. Thank you everyone for your patience. Now, I would like to I hope you enjoy the knowledgeable and interactive session through the day. In this session, we have 7 presentations. Each presenter will be given 12 minutes for their presentation and 3 minutes for question answer. On 12 minutes, I will raise a gentle reminder. There is another request to all the participants that you stay connected with us till the end. If you have any query or update, you can write it to me in the chat box. So just before we get started, I would like to introduce you with the session chair of the session, Dr. Vidya Gaikwad. Dr. Vidya Gaikwad is an assistant professor at Vishwakarma Institute of Information Technology, Pune, India. Boasts over 14 years of experience in academia, she demonstrates a commitment to advancing her knowledge and contributing to cloud IoT security. Her dedication to academia is evident through her active involvement in organizing numerous national and international conferences and her prolific publication record. Ma'am, kindly motivate our participants.
Yeah, good morning, all of you. It's my sincere gratitude for inviting me to serve as a session chair at World S4 2024. So I look forward to engaging with the distinguished attendees. Now, I request the participants to start with their presentations.
Thank you, ma'am, for such a motivating words. Now I would like to extend my welcome to our next session chair, Professor Alexander. He's a professor at State University of Trade and Economics, Kyiv, Ukraine. Sir, kindly address our participants.
Good afternoon. Good morning. Sorry. I would like to say that we have very important and very interesting topics to discuss right now. So let's start. And I hope our meeting will be fruitful. Thank you.
Thank you, sir. Now let's start with the presentation. For the first presentation, I would like to call Moses Olefa for the paper title Air Pollution Prediction Using Shallow Architecture Machine Learning Algorithms. Presenter, you can proceed with your presentation.
Thank you very much. Good morning, Chairman and anchor for the session.
Good morning.
I'll just like to share my slide, just a minute to quickly share my slide with the group before we proceed. Okay, good morning once again. Thank you for the opportunity to present our study to the group of attendees that we have around this morning. I am Moses Olaifa by name, and my co-author is Busumuzi Malele by name. We are researchers from South Africa. So the title of my presentation this morning is Air Pollutant Prediction Using Shallow Architecture Machine Learning Algorithms. And this presentation is divided into 2 to 3 parts, where we have the background and the problem that we try to address in our study. Then we briefly looked at the data set that was used. And finally, we discussed the results from the experiments on the algorithms that were considered. To the background, uh, the pollution of air quality can be caused by nature and human activities due to its impact not only on human but also on economic development. Quality of air prediction has received attention from researchers across the globe. In tackling the problem of air quality pollution, variation in the concentration and occurrences of pollution is a challenge because of the difficulty in tracking these changes by humans. Furthermore, in predicting the future trends, it is highly impossible to obtain accurate forecasts due to high likelihood seasonal changes in meteorological circumstances. Now, the major issue here is that the effect or the impact of pollution on air quality around humans have actually affected the health of a large number of human beings. And in tackling this, different approaches have been used. The initial approach was the intervention by human experts to be able to forecast or track uh, possible changes in the quality of air, which they can use to actually make informed decisions. But this becomes a little bit challenging because we have a lot of factors that will actually impact the best forecast, or let me say the quality forecast of the data sets that are presented to them. So we have different efforts that have been made, ranging from the use of statistical to deep learning models. That is, we have different methods that have been used in the past in addressing this challenge of forecasting the quality of air that we have around us so that informed decisions can be made. Now, from our initial review of existing studies, we discovered that most of the research that have been carried out were based on data sets that were collected from well-established base stations that have advanced or expensive sensors in collecting the data. So majority of these data sets are actually in proper order, which we can actually consider as quality data sets. Unlike the challenges we have in some other areas, maybe like third world countries that do not have well-established base stations with not very expensive sensors that are used in collecting this quality of air. Now, when we consider situations like this, we discover that the data set that is being used is actually marred by a large number of inconsistencies, maybe due to sensor failure at some point, or base station failure at some point, maybe as a result of a lack of electricity and some other things. And you see that in such data set, we have a large number of inconsistencies that can be projected through maybe missing values and some other things. So the majority of the studies that have been carried out were based on what we can call a high quality data set. And we discovered that for the less quality data set, we have very minimal study carried out on this. So our focus was on the poor quality data set, if I'm permitted to present it that way, poor quality data sets that are collected using cheap or non-expensive sensors in not well-established base stations. And what we did actually was just to consider what we call the shallow architecture machine learning algorithms. And we look at how these machine learning algorithms perform in the forecast of the hair quality beyond what we are giving to it through the training data set. So in this study, Prophet algorithm, the random forest algorithm, and the linear regressor algorithms were deployed in the forecast of PM 2.5 concentration using data sets with high level of inconsistency due to large number of missing data, just like I have explained. Now, going to the data set that we used. So the data set that we used in this study is a time series data set from the Air Quality Station 2, Salter Harbor in Halifax. Now, it actually contains a total of 525,000 data points. Now, these were captured using the minute interval. So we had three main features, which would be the date, the time, and the PM 2.5 value, which is a particulate matter values. Now, the particulate matter is just one of the components that actually cause pollution in here around us. So we had a total of 11,200 minutes of missing data points in this particular data set. So what we did was to convert this data points that were taken using the minute interval into the hourly interval. Yeah, we understand that a large number of studies actually consider the daily time interval, but we feel that 24 hours time interval is too large for any changes in the quality of air that might occur at any point in time. And that is the reason why we consider the hourly time interval. So with this hourly time interval, we had close to, I think, 200 or more than 200 hours of missing data from there. So what we used in filling up the missing data was the time interpolation. This is just part of a major study that we are carrying out, because in some other studies, we actually use some models in filling up the missing data, and we try to see how some deep learning algorithms can actually work in forecasting the quality of time over a period of time. So we had a total of 8,755 hours of data. Then we separated this into two sets. One side is the training data set, while the other is the testing data set. So we had like 8,395 hours of training data set, which is more or less like around 11 months of data set, of air quality data set. Then we have 360 hours of testing data set, which is approximately a month of air quality data. Now, from our experiment, like I mentioned earlier, we studied the performance of the Prophet algorithm and the performance of the linear regression algorithm, as well as the performance of the random forest algorithm. So what we discovered was that the Prophet algorithm did not fit the data set properly. It performed poorly in fitting the data set. Now, we assume that this was caused as a result of the changes in trends and seasonality in the data. Like I mentioned, we have quite a number of missing data sets that were here, and we had to use time interpolation to fill up that data set. Now, it was kind of illogical to actually remove the missing data because we're working on time series. So every point in time actually has a role to play in the building of the model. So we use the time interpolation. So we feel that the reason why the Prophet algorithm did not perform well was because of that changes in trends and the seasonality, which might have been contributed to by the missing data. And then we have the linear regression. Now, the linear regression actually fared well in this forecast. Now, when we compare with the actual data set, we see that it actually performed better than the Prophet algorithm. Then we look at the random forest as well, which equally performed well. as compared to the profit algorithm. Now, in this chart, we kind of combined the actual PM 2.5 values, that is the actual values of the particulate matter. Then we compare with the linear regression forecast as well as the random forest forecast. Now, we can see that the linear regression forecast that we got was very close to the actual values. And so we can hardly see it coming out, or we can hardly see it except for some areas, maybe the highs and the low values, maybe the max and the mean values around some seasons. But we can see for the random forest that, yeah, we can obviously see the differences or the gap between the highs and the lows of our graph. So this actually gives an impression that the linear regression algorithm performed better than even the random forest for this type of data set. Then here we just have some metrics that we carried out. That is the measurement of the models. We measured the performance of the models on the training set as well as the test set. So for the training set, we measured the MSC and we measured the RMSE, we measured the MAE, and they measured the R squared. Now for the first three measurements, now the lower the values tells us that we have a better model, then the higher the values tells us that we have a poor performance by the model. And for the R squared, the more we get closer to one, it tells us that the model actually fits well with the data set. Then the farther we are away from one, that is towards the zero mark, it tells us that the model did not fit properly to the data set. So we can see that for the training set, we have the perfect algorithm struggling to actually fit with the data set as compared to others. We have minimal error being recorded by the linear algorithm and the random forest algorithm as compared to the prophet algorithm. And when we check the R squared, we see that the prophet algorithm actually gave the least R squared measurement as compared to the linear and the random forest. And when we go to the validation set, we can see that the last two algorithms actually gives better performance by giving us a lower values as compared to the prophet algorithm. Then when we check the R square measurement, we see that the prophet actually tended towards the negative side than the linear and the random forest algorithm. So just this is just a summary of the experimental result of our study. So that will be the end of my presentation. Thank you very much.
Thank you, sir. So, and ma'am, do you have any question?
Yeah. Yeah, Moss, your presentation was too good. Can you go to the experimental results slide, the first slide, figure 1? Yeah, here the experiment and result is there. So is this the year considered 2017 and 18 has been considered here for the time step? In the graph, it has been mentioned the years 2017 and 18. Am I audible to you?
Oh,
Hello.
thank you very much.
Ma'am,
Sorry,
you're
I
audible.
was muted. I was muted. Sorry about that. Sorry about that.
Yeah.
So the result that we presented here
Hmm.
is just for the predicted period, the time we forecast. It
Okay.
didn't include the training period. So like I mentioned, we forecasted for the last month, which is between the 11th month, which was sometimes in November, sometimes in December. So I think the time that you can see here, that is the 2018 you saw here, was just an addition just to pad the graph so that we do not miss any data on the graph. That was why you have 2018 1st of January 2018.
Thank you. Yeah. Over to you, sir. Hello.
Thank you, ma'am. So, do you have any questions? Okay, let's move to the next presentation. So, please allow me to share. Thank you. For the next presentation, I would like to call Nurbek Torev for the paper title, An Econometric Analysis of the Factors Impacting the Foreign Trade Operation of Entrepreneurial Firms. Presenter, you can proceed with your presentation. I think so, sir is facing some network issues. It's okay. Let's move towards the next presentation. For the next presentation, I would like to call Natikau for the paper title, An Effective Approach to Ensure Brand Safety in Online Advertising Using Image Multiclass Classification and Deep Learning. Presenter, you can proceed with your presentation.
Thank you, Professor, and good morning, everyone. My name is Nhạn Thị Cao. I'm from the University of Information Technology, which belongs to Vietnam National University, Vietnam. So I would like to present our paper, An Effective Approach to Ensure the Brand Safety in Online Advertising Using Image Multiclass Classification and Deep Learning. So I will present following this content. So the first part, the introduction part. We all know that the online advertising plays very important roles for businesses, and as shown in the white paper on the brand safety. Brand safety solutions protect brand safety during online advertising, avoiding placing ads on the websites with inappropriate or illegal content. And we know that one website has many different objects like the text, images, video, and so on. So we observe that almost a website contains many images. So identifying unsafe images is a suitable approach to solve this problem. So this work aims to propose an effective method to avoid unsafe websites in the examination phase to ensure the brand safety. So I move on to the related work section. There has been a lot of research on the identifying unsafe images. So depending on the goal of the research, different methods are proposed to detect unsafe images. So if we focus on the category, the most of the studies are single category, such as the outdoors category, war category, weapon or gun category. They there is little research for many unsafe category for the brain safety. So our initial research proposed a method can detect 5 unsafe classes, including adult war, gun, knife, and gambling chip. In case we focus on the learning models, deep learning models are mainly chosen for almost all research. CNN convolution neural networks are used in many works, and some studies they use CNN combined with some other features to improve the accuracy. And the others use pre-trained deep learning models and fine-tuned models to solve specific problems. And based on the previous method, we found that even they has advantages, including identify 5 unsafe classes for the brain safety. However, there are still issues can be further studies as follow. The first one, detecting more unsafe classes. The second one, evaluating the performance of original models and its pruned models. And the last one, feasibility for practical application. So we proposed our method to solve these problems. Before that, we examined some previous work like the VGG network or deep residual learning. We know that the CNNs have demonstrated excellent result in image classification. However, there are still some challenges such as difficulties in network design or the existence of degradation issues. This topic, VGG network and deep residual learning are 2 approaches to solve the challenge mentioned. And both VGG and ResNet are effective pre-trained models and can be fine-tuned to successfully solve many different classification topics. That's why our work is also use them to solve the problem of brain safety. And the next one, this is about the network pruning techniques. So pruning is used to reduce for reducing the model complexity by removing less useful filters in a CNN. The main phases of pruning procedure including 3 steps. The first one, training a large over parameter size model. And the second, pruning redundant architectures or weights. And the last one, fine-tuning. So different criteria in picking what should be pruned created a variety of pruning methods. So here we list here some pruning methods like L1 norm-based filter pruning, a regression-based feature reconstruction, a network slimming or TNet. So the last here, this is our method. The method aims to meet criteria of brain safety. So we observe the unsafe categories, the accuracy, model size, and the inference speed. And actually, currently, we cannot find any shared data set for this brain safety topic, so that we have to build our own data set to conduct experiments. So we select 7 unsafe classes are adult, war, gambling, chip, gun, knife, alcohol, and cigarette. This data set includes the most common safety categories so that it can be applied in almost all ranges. And to reduce the training cost, we use the popular pre-trained models and then fine-tune them on our brain safety data set. And we use Some pre-trained models are VGG, ResNet 34, and ResNet 50. And we also applied the pruning techniques. For example, here we use network slimming used to prune the VGG and L1 norm-based filter pruning using to prune the ResNet 34 and the regression based on feature reconstruction TNet 30, TNet 50. And here we can see the experiments and result. Our data set. The data set is built based on 3 main steps: category selection, data crawling, and data cleaning. And finally, we have the data set as shown on the screen. Right. We have totally 8 classes, but 7 unsafe classes and 1 safe classes here. And this is the experiment models. And here we can see the experimental process here. Because we try to observe the accuracy, inference speed, and model size. So I will show you the result here. This table shows the experimental accuracy. So the table shows that we have good accuracy for all of our models. In case we compare the difference between the original model and the pruned models, we can see that the pruned models slightly decrease accuracy, just from the 0.5% to 2.5%. And we try to analyze some wrong situation. For example, here we have some safe images are predicted as alcohol. So this is daily activity images, and it's detected as the alcohol. It's wrong situation. And the others, this some images, some safe images are predicted as cigarette. So we can see here pen and classes, they are very easy to misunderstand as cigarette. And here we still have some other situations. Cigarette images are predicted as safe. So in these images, we found that the cigarette area here, display, they are too small to be recognized. And we have the last situation. In these images, the cigarette images are predicted as alcohol. So actually in these images, we found that the images contain both cigarette and alcohol. But at the beginning, when we label, so we label as the cigarette. Okay. So we move on to the inference speed indicators. So this table shows the inference speed. The inference speed here is calculated by an average of 100 runs and measured in the frames per second. And we list here the inference speed of batch size, some batch size here. So we can see that the pruned models show the better inference speed. The model size. So this table shows the model size of all of the models we have here. So we have very good model size after pruning. And it shows the potential for applying in the real system. Okay. And we try to compare the inference speed and the accuracy because we think that it can show ideas to select a suitable model for specific application. For example, in this case, if we focus, if the application focuses on the accuracy, we can choose this model L1 ResNet 34. And in case we mainly focus on the accuracy, maybe we should choose this group of models. Yeah, and here, this is our conclusions. This work presented an effective approach to ensure the brand safety in online advertising using image class, multi-class classification and deep learning. So first, we created a data set with 8 classes, and then pre-trained models and pruned models are investigated and are adjusted to solve the brand safety issues using multi-class classification on images. This approach greatly reduced the model training cost while still achieving the given key performance indicators. I mean here accuracy, inference speed, and the model size. And experimental results show that the proposed method achieves good performance and has potential for application to real systems. However, this work can be improved in the following issues. The first one, research on adding new unsafe classes will remain the high performance. And the second one, research on improving accuracy, especially for images that contain the meaning of subclasses or unsafe area. In images, it's too small. This is the end of my presentation. Thank you.
Thank you, ma'am. Now I request session chairs. Do you have any questions, sir and ma'am?
Yes. Nan, your presentation was too good, and your topic is also recently booming a lot. You are working on the brand safety, right? Hello.
Hello, I'm here.
Yeah. You have tested your performance based on 3 parameters, that accuracy, model size, and inference speed. Why you chosen only 3 parameters? Why not some extra other parameters?
Actually, I show you. We try to analyze our result based on the accuracy, inference speed, and model size, because we think that these indicators we can, if we understand clearly our models, we can select the suitable one in order to apply it in the real systems. So that's why we choose that.
Okay, go to the next values for accuracy.
Yeah, right? Yes.
Yeah, the which has been highlighted in bold. These are your values, right?
Based
Slim,
on
Slim VGG 11. These are your values.
Yes. Actually, based on our experimental result, we found that except the Slim VGG has a higher the accuracy. All the other models, we have the slightly decrease the accuracy. But actually, we can see that the VGG here, we have the lowest value, the lowest accuracy. The others, for example, here, ResNet 34, ResNet 50, we have very high accuracy. So that's why I think we think that we should focus on this group. Yeah,
Correct. And
yes.
whatever the models you have mentioned, are these the rest other models of whichever the papers you have referred? these models belong to the recent current models like which are implemented in 2023 or 2024?
Sorry, I cannot hear you clearly. Are you talking about the references, right?
Right. Whatever the references you have mentioned in the slides, are these the references recent current research work?
Actually, this worked based on our group previous research, and I try to find some papers, new research in these topics, but I cannot find.
Okay.
Yes. People maybe they focus on the single category, like the how to detect the gun or how to detect gun, many kinds of gun, for example, like that, or adult, something like that. But for the brain safety, I cannot find any data set to test our models. So we have to create our old data set.
That's good. Also, you have selected some unsafe classes like adult, gun, and knife, everything. That's good. Okay.
Thank you.
Yeah. Over to you, sir.
Thank you, ma'am. Sir, do you have any questions? Okay, sir is not having any questions. Ma'am, kindly allow me to share.
Yes. Stop sharing. Thank you, sir. Thank you, Professor. Thank you.
Thank you, ma'am. Now let's move towards the next presentation. The next presentation I would like to call Eduardo Proven for the paper title Enhancing Multi-Class Imbalanced Fake News Model with Linguistic Features. Presenter, you may proceed with your presentation.
Good morning, sir. Can you hear me?
Yes, sir, you're audible to us.
Yes, sir, you're audible. Yeah.
Good morning.
Yeah, good morning.
I want to share, please, share. Good. Are you seeing my screen?
Yes, sir, your screen is visible to us.
Okay, thank you. Good morning to everyone. Thank you for having us here. We are going to present our work titled Enhancing Multi-Class Imbalanced Fake News Models with Linguistic Features. So, as introduction, in the present, fake news are prevalent and rise across several media platforms. Yeah, fake news are a very important topic in machine learning and artificial intelligence at all. There are various approaches that aim to detect news and fake news through methodologies such as machine learning and natural language processing. However, with machine learning, we have significant accuracy issues due to class imbalance. Class imbalance is a problem in machine learning because the models in general cannot generalize very well when they face imbalanced data sets. Typically, models use two classes for their training, real and fake. With the fake classes, the fake patterns being the minority. In this work, we address the class imbalance using linguistic features and using techniques to balance the dataset to improve our metrics. So, what we did, we use an imbalanced misinformed dataset to calculate linguistic features. So in table 1, we have the linguistic features we use in this work. We have a dataset with news and from Twitter, and those news were labeled as different classes. So we have a set of characteristics, features, and then we use balance techniques used in literature, such as smooth, random undersample, and random oversample to balance this dataset. As I said, the table 1 shows linguistic features such as number of paragraphs, total of sentences, mean of sentences, total of words, max of characters, etc., etc. In figure 1, we can see the diagram of our methodology. We start from having the dataset and extracting the linguistic features, and then we construct the training and test set to apply our models. So first we have a sample from the dataset and we convert it to the training set. This training set is imbalanced. So we teach, in the first place, we teach to the models with an imbalanced data set. And we have a test set, so it's also imbalanced to improve and to try to model and prove our hypothesis with this kind of realistic data. And then with the models, we obtain the metrics and compare the methods to see which one performed better. So for the experiments, we have a dataset called CL News. This dataset is a Spanish dataset of news extracted from Twitter. And there are labeled with different classes. In table 2, we can see the distribution of the dataset. We have labeled no rumor verified, and as you can see, the training set is imbalanced. We have 86 news from labeled as no rumor, 40 labeled as false, 75 labeled as true, and the not verified news are labeled. We have 39 not verified news. So as you can see, the test set is also imbalanced. So for the training phase, we teach the models with this training imbalanced dataset. So as we can expect, the models learned more from the no rumors news. So as this dataset is imbalanced, we try different approaches, different models of machine learning to see what happens when you balance this kind of dataset. So we use XBoost, SVM, Random Forest, and AdaBoost, the ensemble learning method AdaBoost. As metrics, we use accuracy, precision, recall, and F1 score to see how the models perform. In the first place, we try the experiment with the imbalanced data. As you can see, SVM and XBoost have different accuracies and different numbers, precisions, and recall. So for you to see how the models perform, we present here the confusion matrix for the XBoost performance for the test set with the imbalanced data training. Yeah. The accuracy is low, yes, because we have different classes and they are imbalanced. Sorry. Sorry. Then we try to balance the dataset with different methodologies. As I said before, we use S-mode, random undersample, and random oversample. In this case, the accuracy improved, but above all, the recall of the dataset improved. So the models improved a lot with the use of different kind of sample methods. We present here the same confusion metrics for the same method, XBoost, and as you can see, the diagonal improved in their scores because of the balanced dataset. I would like to make clear that the sample methods generate, in some cases, synthetic data, so they can reach the number of the different classes. Yes. As you can see, the results for the balanced data show that XBoost exhibit a high metrics, especially with random oversample technique, and random forest has good performance with the random oversample and the S-mode technique. In contrast, SVM and AWS have not good performances. So, in conclusion, XBoost and random forest are the most effective in our experiments for to model fake news and to detect fake news using different kind of sampling methods. As I said before, our dataset is difficult because it's in Spanish. So to label the news needs different approaches, and to generate the gold standard is also a challenge. It is necessary to address the problem considering both techniques and models, and in the future, we would like to try different techniques and maybe use some kind of generic models or a kind of different approaches to generate more and better news based on this dataset. So this was my presentation. Thank you.
Thank you, sir. Now I request session chair. Ma'am, do you have any questions?
Only one question. Only one question. Yeah. Hello.
Yes, ma'am.
Yeah. Yes, sir. You mentioned about linguistic features, right? So, whatever the features you considered, right? So, does this feature come under morphological, syntactic, or semantic or pragmatic features?
Thank you for your question. If I understand you, you are asking me if we use other features different from the numeric features as we show here, right?
Yes, correct.
Yeah. We would like to try different linguistic features. For example, we are trying to use now coherence and cohesion features to improve the characterization of our data set and to see if the meaning of the intention of the class, for example, you have false news, but this false or this label can you can obtain it because, or maybe the news is incoherent, right?
Yes.
Or a true news can be true because it's well written, but it have not cohesion in the words of of the meaning. So
Yes.
in the future, we would like to try those kinds of features to improve this characterization and maybe improve the presentation of the results.
Yes. Good. 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 That's from my side. Yeah. Thank you.
Thank you, ma'am.
ma'am. Alexander, sir, do you have any question?
I have one more question, if you please. How do you think? Can we use any elements of artificial intelligence in your work? Maybe, for example, for to investigate these multi-class models you have proposed. Thank you.
Thank you, sir. If I understand you, you asked me if we use some AI methods in this, or in the future, we can try different methods of AI.
Yes, I means this question, yeah.
Yeah. Yeah. As we explained here, we only use machine learning methods to try to understand what happened when the data set are imbalanced. Yeah. But as you say, sir, we could try, or we can try in the future, different approaches. For example, deep learning approaches, or we would like to try some different natural language processing methods to understand, as the ma'am says, different characterizations, or maybe we would like to try new generation models to generate, as I said, synthetic models. So we would like to try in the future different methods and different approaches to understand this data set, and maybe we would like to try better, or we have better metrics.
I understand. Thank you
you.
very much.
Thank you, sir.
Thank you, sir. Sir, please allow me to share my screen.
Yeah, thank you. Bye.
Thank you. Now moving to the next presentation. For the next presentation, I would like to call Karola Kurbanov for the paper title, Evaluating the Influence of Regional Economic Factors on Local Budget Revenues Using Econometric Models. Presenter, please proceed with your presentation. I think so, sir is facing some network issues. So let's move towards the next presentation. For the next presentation, I would like to call Laura Alma Diaz-Torres for the paper title, Predictive Analytics for Fleet Reserve Assimilation. Presenter, please proceed with your presentation.
Yes, thank you. I will start my camera so that everyone can see me too. And okay. So you're seeing my presentation right now, right?
Yes, it is visible to us.
Yes.
Okay. All right. So let's start. Well, hi, my name is Laura. I work right now in the public transportation in Mexico City, in one of like a group of many companies. So this is an effort with Juan Marco Antonio Hernández Godoy y Mario Leonardo Nieto Antolines. One of those is my boss, so I'm so grateful to be here. So let's start. Yeah. So introduction. Well, what's the objective of this? We propose a methodology to use a predictive analysis to determine the reserve fleet in the transportation business units in the in Mexico City in the system for bus rapid transit. This to ensure that the bus availability meets the schedule at the operational efficiency, and also to handle maintenance and inspections, because in Mexico we have inspections from the Metrobus. So what are the challenges here? Well, the service disruptions are due to an inadequate reserve fleet. So a solution we found was a robust methodology to calculate the technical fleet required to safeguard the operational efficiency. So it was required to consider that the fleet needs 3 types of maintenance, and also the regulation and inspections mandated by the Transportation Authority in Mexico City. We also consider that failures in this methodology as obviously a case that can disrupt the service in Mexico, right? So the maintenance, we have 2 types of maintenance: the planned maintenance and unplanned maintenance. Obviously, the planned maintenance, we have the preventive maintenance and the improved one. And the preventive one is like a time-based maintenance or a condition-based maintenance. In this case, we consider the condition-based maintenance because of the contracts that work in Mexico. And for the corrective maintenance, we use our Markovian model. So the percentage of reserve fleet was calculated by this formula, and this formula is representing the daily fleet that we need for preventive maintenance, the fleet that is required by authority, and also the fleet for corrective maintenance. So preventive maintenance, as I said, is a schedule based on the kilometers that we have done with each bus. So we took the average of the total kilometers per month and the total fleet and the recommended preventive maintenance for the calculation of the monthly fleet and daily fleet that needs to be under maintenance each day or each month. For the inspections, the periodic inspections are mandatory for Mexico. So we took all the fleet that requires these inspections, and we divided the operational fleet by the days between inspections. And now we go to the corrective maintenance. The corrective maintenance, of course, is unexpected. It's something that we cannot say, oh, it's going to happen that day at that time or anything. So what have we done? We use a Markovian model to process all the data from 2024. And with this, we propose like a prediction and the model with the probabilities between the states. So once we had the 2 states, we only took these 2 states because the database is really, really hard in Mexico. It's really difficult. We don't have a database that can tell us which component failed. We can only say it failed, and that made a disruption in the system. So we only took 2, available and unavailable, and that was it for us. And we had, again, a lot of problems with the database because it cannot be completely reliable. Of course, this kind of failures that the buses have are reported by the operations, the operational part of the service. So they are not mechanics. So we cannot trust them completely to say, oh yeah, that was the cause of the failure, and that's why we weren't able to use the component part. But at least we used this one. So it was necessary to do some data transformation, the transition count, the calculation of probabilities, and the distribution, okay? So we took 5 companies that use different buses. Some of those are double-decker buses. Some of those are electric ones and new, because this is a new technology in Mexico. So we took different companies, and we have a lot of buses. for company A, for example, it was 42 buses, but our biggest company was company B with 93. And the kilometer for the preventive maintenance was the recommended by contract for each of the companies that had bought the buses. So that was some kind of stuff that we couldn't just handle or estimate, but it was more like what the paper said. So with this, it was clear that, of course, if you have a little less fleet, but it covers a lot of kilometers, you're going to be needing more daily fleet for preventive maintenance, like what happens in company B. Also, if the transport authority requires at least one annual inspection, we took like the value to 360 because of course there are going to be some days that we don't work. So that was the first calculation we did. And then we went to the Markov machine factor and the corrective maintenance. So we used the Markovian model to predict the likelihood that each vehicle will require a maintenance based on its historical data, and how this maintenance needs to be corrective and not preventive. So we, of course, found some really different things for each company. For example, for company A, the maintenance is not done in the company, it's a third part that does it. So the Markov machine factor shows that. It shows because it's way too little for the fleet that it has. While, for example, in the company B or the company D, we have that the maintenance is done by the same company. So sometimes it's a lot of job and they can cut up. So it becomes real difficult. So taking all this into the formula, we found that, for example, the worst company, it could be company B because it covers a lot of kilometers and they don't have as much buses compared to, for example, company A that has only 40 buses, but the kilometers that they cover are much less. So the ratio is different. So we can see this ratio in the corrective maintenance, also affected by who does the maintenance. If they do it internally, or they go with a third party. So that's a big difference. And we found this. So applying our predictive analytics methodology across many different companies has yielded a significant insight into optimizing their fleets. Each company, of course, presented a unique operational characterization, demonstrating that the approach is flexible and it's effective. The results for this case of study highlight the importance of a predictive maintenance approach for each company. Now that we know, hey, you need more fleet, we can add, there's like two ways to go right now. You can go and say, hey, I need to do less services and I need to stop a little bit, or I can buy more fleet and then upgrade everything, right? So the percentages of technical reserve fleets across the companies underscore the necessity of adapting maintenance strategies to the operational context. The result allows the companies to have a better estimate of the fleet that they required in reserve to ensure that an adequate maintenance and also an adequate operational system. And also the companies were provided with the results so that they could go to the authority and say, hey, I need help, because in Mexico, the transportation system, it's kind of like private, but also the government is in it. So it's a job, a collaborative job. So the authorities also need to be a little bit more responsible for planning and creating the transportation and consider like the responsibility they place on these companies that have a little fleet and they have to operate for big and long kilometers, and this could jeopardize the operability of the service. And that was it. Whatever questions you have, this is my this is our contact information. The last one is from my boss and the director of my, I don't know, my area. So we are open to receive those.
Thank you. Now I request session chair. Do you have any question, ma'am?
Yes, only one question. I hope you are familiar with the term telematics, right? So what telematic factors you considered for the preventive maintenance?
Sorry, can you repeat that for me, please?
Yeah, I hope you are familiar with the term telematics, which is
Oh,
used
yeah.
in modern fleet management, right? So what factors did you consider for preventive measures related to telematics?
So actually, Mexico, we have a problem right now with telemetrics because of how we work with the government and how Grupo CISA is working. It's really difficult with telemetrics. We are not sure of the information. It's failing a lot. So telemetrics wasn't an option here, and we are hopefully going to use it later on and see it as a future path. But right now it wasn't in the table because telemetrics are failing us in Mexico. So that became really difficult.
Okay, good. Okay, done from my side.
Thank you, ma'am. Alexander, sir, do you have any question?
And I have one more question. Thank you. My question is connected with different ways of this forecasting. How do you think? Can we use, for example, graph methods for forecasting, or maybe transportation problems, methods on transportation, or routing methods, routing problem for this forecasting? Thank you.
Sorry, I couldn't understand you.
We have different methods for forecasting and different methods for analysis of fleet reserve estimation. For example, transport model or a logistic model, or maybe someone else graph model with consist in connecting all different sites and different elements into one difficult structure of contacts or different ways of fleet reserve. How can we use these models for predictive analysis?
We are not sure yet because Grupo CISA is a company that has well, it's a group of companies that has 22 companies inside. One, 5 are from the bus rapid transit system, and the other ones go from the conventional buses that go by the city and have to stay in the traffic to buses that are kind of private and that you can go up to an app and make a reservation. So this was our first try with the bus rapid transit system, because with the other ones, we don't have a correct database to ensure that this methodology works yet, but that's kind of what we are hoping to go and what we are hoping to do. So right now, I don't have an answer for that question, but I hopefully in 1 year, I will tell you all about it.
Thank you. And one more question, if you please. I know that in different investigations, someone have different multivariant types of forecasting or multivariant types of predictive analysis. For example, optimistic one, pessimistic one, maybe trend one. How can we use this different multivariative analysis in your investigation? Thank you.
Thanks. So I think that right now with we bought a lot of new fleets to the electric fleet, for example, and we could use the data we have to go to an optimistic kind of measurement and kind of prediction, because we are hopefully having this fleet for at least 10 years. But it's just really hard when you don't have the data. For example, the data was given by the government, so it doesn't have a lot of specifications. It doesn't have, for example, which year is the bus, or which model, or which. That was all internal work from my company. So we're hopefully going to expand these methodologies so that we can do different paths and see if, for example, one type of fleet is more convenient than the other one, and go a little bit more optimistic or a little bit more to the other ways. Right now it's really difficult because we are going through a transformation in Mexico. So data has become a problem. We have numbers, but we don't have information yet.
Thank you very much. Very important research and very important report. It was very expressive, very interesting for me to listen to your report. Thank you.
Thank you.
Thank you, sir and ma'am. Ma'am, please allow me to share my screen.
Sure.
Thank you. Now let's move towards the next presentation. For the next presentation, I would like to call Grozeda for the paper title Preliminary Surface EMG Profiler in Parkinson's Disease, a Foundation for Objective Disease Severity Assessment. Participant, you can proceed with your presentation. Ma'am is resolving her issue. Let's give the final call for the last presentations. For the next presentation, I would like to call Nurbek Turyev for the paper title An Econometric Analysis of the Factors Impacting the Foreign Trained Operations of Entrepreneurial Firms. Presenter, you can proceed with your presentation. It's okay. Let's move towards the next presentation. For the next presentation, I would like to call Karla Kurbanov for the paper title Evaluating the Influence of Regional Economic Factors on Local Budget Revenues Using Econometric Models. Presenter, you can proceed with your presentation. I request you to share your recorded presentation to the conference mail ID. There will be no effect in your publication. Thank you. Now we are moving towards the closing remark of the session. Ma'am, I again say you can share your recorded video to the conference mail ID. There will be no effect in the publication. Now let's move towards the closing remark. I sincerely thank our authors for their excellent presentation and contribution in the session, and all our participants for being a part of this international conference. I hope the session was informative enough. We, on behalf of the whole team, thank you for your support during the 8th version and the previous 7th version of the conference. We'll be very happy to see you in the 9th version in 2025. All the presenters will be getting their digital certificates within 2 working days. Further, all the papers are already forwarded to the Springer for publication. The publication will be live in 6 months. Kindly cooperate with the team of World S4. I also thank our session chair, Dr. Vidya Gaikwad, for chairing the session. This is the token of appreciation from World S4 team and Global Knowledge Research Foundation and partners. Thank you, ma'am, for your valuable presence. Kindly address our participants, ma'am.
Yeah, it's really an honor and a privilege to be considered for such a significant role as a session chair. I would like to give 2-3 suggestions for the presenter. That your presentation should be in a point-wise manner, and whatever the table values you're putting in the table, they should have some measuring units should be mentioned. Based on the values, we will not be able to understand what are these values are, right? These are the 2 suggestions from my side. Yeah, I hope this will be helpful for your next presentation. Yeah, thank you. Thank you, Karthik sir, and thank you, Richa ma'am, for giving me such responsibility. Thank you. And also, I would like to thank Dr. Alexander for sharing with me. Yeah.
Thank you, ma'am. Now, I would love to extend my gratitude towards our next session chair, Professor Alexander, for chairing the session. So, this is the token of appreciation on behalf of the whole team of World S4 and Global Knowledge Research Foundation and partners. Sir, thank you for your valuable presence. Sir, I request you to address our participants.
Thank you very much. And I would like to express my sincere respect to all speakers on our conference team. And I would like to express my unique positive impressions with different reports about air pollutant predictions, about predictive analysis for fleet reserves estimations, especially. Maybe, of course, I have to say that fake news models with linguistic features, it was very remarkable report, and it was very unique and non-standard approach to investigate this fake news. Of course, I have to remark brand safety in online advertising with image multi-class classification usage, and I think, not I'm sure, that our work was fruitful, and I would like to thank to every speaker once again. Thank you.
Thank you, sir, for such a knowledgeable words. Now, I request everyone to turn on their cameras for a quick snapshot of the conference. I request everyone to turn on their cameras for a quick snapshot of the conference. Thank you, everyone. Stay safe, take care, stay connected. Thank you.
Thank you. Bye.
Thank you.
Thanks,
Bye.
sir.
Yeah, bye.
Thank you, ma'am. See you all in the next 9th version in 2025.
Yes, definitely. Yeah, thank you.
Thank you, ma'am. Thank you, Alexander, sir.
Thank you very much. See you.
See you, sir.